Welcome to Maze Leetcode Challenge. This problem is called n queens. The n queens puzzle is the problem of placing n queens on an n times n chessboard such that no two queens attack each other or are able to attack each other. Now, given an integer n, return all distinct solutions to the n queens puzzle. Each solution contains a distinct board configuration of the n queens placement, where queen represents the queen and period represents empty spaces respectively. So here we can see with a 4x4 chessboard, there's going to be two answers. We have one configuration that looks like this. You can have like empty q, empty, empty, like on the first row, empty, empty, empty q on the second row, so on and so forth. Here with n equals 1, we only have one solution, queen right in the middle. So constraints, we only can go from 1 to 9. Now you would think there might be some sort of pattern that we can use, but I don't think that's what they're trying to do here. They want us to just write something recursively to give us the solution. So here's what we're going to do. We're going to do a depth first search, and we'll start at the first row and start at the first column. Now if we place the queen here, we know that we can't place any more queens on this row, right? We know that intuitively. But on the next row, we know there's certain places that we can't place a queen after that either. So what we'll do is do a depth first search at each row, and whenever we call another recursive call, we're going to pass in all the cells that are excluded. So here, if we started here, we're going to include this cell here, this cell here, this cell here. So everything beneath it, as well as everything to the bottom right diagonally. So it would be like all these oranges can't work, and everything to the diagonal to the left as well. Now you might ask, well, what about the ones like horizontal? Well, we don't need to worry about that because at each row we're only going to place one queen, and really the only thing we're concerned about is the next row each time, right? So we don't need to worry about all the cells above us that get excluded either. So only the ones beneath. Once we finish all the rows, if we have some sort of answer, then we could add that to an output, and then so on and so forth. So we have two things we want to pass in. We want to pass in a list of all the row configurations, okay, and that's going to give us, we can just take the length of that list to know which row we're at. And we also want to pass in, let's say, a set of all the rows and columns that are excluded, okay. And normally you can do this by backtracking, but we're not going to actually have to do that here. We just need to pass in a set and do an overlap union of these sets to keep passing in our recursive call. So let's start by first initializing our output, and we're going to create a depth first search. And what do we want to pass in? We want to pass in a list of our answers so far, so called path, I'll just call it L, and we also want to pass in a set of everything that's excluded. So that set is going to just look like something like, I don't know, tuple, like the list of tuples with everything that's excluded afterwards. So like 1, 2, I don't know, 1, 2, 3, so on and so forth. And we have to remember there's going to be three things we got to keep track of: everything beneath, everything to diagonal right, and everything to diagonal left. All right, so we have two conditions, right? First, we want to check to see if our, well, let's first start with the n. I guess n is going to be the number of rows, so we don't need to calculate the length anywhere. We'll just say if length of L is less than n, we want to continue this recursive call, right? Otherwise, if we find that we have enough rows, then we're just going to add to our output whatever our list is so far. All right, so next, we have a couple things we want to do here. First, we want to check every column, right? So every column inside this row, we're going to create like a temp string and add it to our L here. That's going to be the path. And we have to do that for every single column. Okay. So let's see. I suppose we'll start with 4 C in range of n. That's going to be the columns. And we should have the row here too. So the row is going to be what? Length of L. I should probably just count that here. Row is going to equal length of L, and we'll just say if R is less than n. Oops. Okay, so for C in range, blah, blah. Okay, so now we want to first check to see our any of these excluded. So if RC is in the set of excluded, then we're just going to continue, because this can't be an answer. We can't place a queen here because otherwise some queen above us can attack. So we just continue here. All right, so let's see here. So let's first start off by creating our temp string. So temp, I'm just going to make that equal to, let's see, periods times, depending on what column we're at. So depending on what column we're at, let's say times C plus a Q plus periods again multiplied by NC minus 1, I believe. Okay, and that's going to give us what this configuration at this row looks like. Okay, now before we add this to our L, let's first calculate all the excluded cells here. I believe that needs to be in this for loop. Let me check. Yeah, so I believe so. So we'll have to create another excluded set here to begin, because we want to reset this every single time we set a new queen, right? So first, everything on the bottom. So bottom diagonal right, and bottom diagonal left. So everything at the bottom, how can we do this? For, let's call it R1 in range of row to N. Everything at this column we have to add. So let's add a tuple of, let's see, row 1 and C. Okay, now we want to do for the bottom diagonal right. So I'm going to do that in a while loop. And to do that, I guess I'll just say, let's see, R2 equals R3, which we'll say equals to row. And we'll say C2 equals C3, which equals C. And the reason I'm going to do this is just make it a little bit easier to go to diagonal right. We'll say while column 2 is less than the length of the columns, so that's going to be N. And we need to actually keep track of the row as well here, right? So what we'll do is we'll increase row to 1, and we'll say increase 2 also to 1, and then we'll add that to our R2 and C2. And we'll do the exact same thing for the diagonal left, right by here. But this one will say while it's greater than 0. Is it greater or equal to 0? Let's see, greater than 0. Okay, I think it's just greater to 0. So this one will be C3, but with these ones we're going to subtract, right? So row C3. All right, so now we have a set of all the excluded cells, and what we'll do is just recall our def first search. We'll say def first search. After we add, well, I guess we can just add that here. We'll say L plus, let's see, L plus, are these lists? So we have to append it to the list. I think that should be fine. We'll just L plus the temp in a list like this. We'll say excluded, and we'll use the OR symbol. That's going to give us the union of these sets to the X right here. And I gotta make these tuples. All right, so I believe I have everything here. Now let's make sure that it runs. So let's call our def first search, starting with an empty list and an empty set. And now we should just return the output. All right, so let's see if this works. Okay, so that does look like it's working. Let's go and submit it. And there we go, accepted. So to be honest, I'm surprised that worked the first time, because yeah, this definitely took me some time to figure out. It's not an easy question at all, even though it's straightforward. But time complexity wise, I believe it's n factorial, and we do use extra space because of all these sets in L. I'm not quite sure how much space we use. I believe it's also n factorial as well. So yeah, this definitely works. There's definitely ways to optimize this and make it look better, but you know, for me this was the most understandable, so I'm just gonna keep it with here, and I think we'll end it. So thanks for watching my channel. Remember, do not trust me, I know nothing.